If you've never been to a machine learning conference before, or if you've been to one but not to EMNLP 2022, then come with me. Let me show you. This is the Abu Dhabi ADNEC conference or convention center. It is where the EMNLP 2022 conference is being done. It's one of the main conferences for NLP, for language processing. In this special edition of Talking Language AI, I'll be taking you over my journey, a little bit of how I experienced MNLP and some of the interesting ideas and people that I came across. I'm now walking inside of the convention center. It's this massive building. There are these rooms, workshop rooms at the top. That's where the workshops were held in the first few days. As we start to enter this area, we start to hear the murmur of poster chatter. And as you get past the posters, you get to this area with the red, and that is where the booths are. This is a quick look at all the companies. And for the majority of the conference, I had been here in booth number 10. So here it is. Aside from the workshops and the sessions, a lot of the better things that you gain is talking with people and exchanging ideas and seeing, what's popular, what's not popular, what do people think about different things. And so I met a few people, a few researchers, and I've asked them a few questions. And here are their answers for you. I've asked 3 questions to a bunch of these awesome researchers you'll see in a bit. So the first question was, what was the most exciting development in NLP in 2022?
The growing accessibility of large language models. With big science and Eleuther AI models, a lot more people are now involved in large language model research, and they've become a lot more accessible. People can get their hands dirty, and through that we've also identified a lot more shortcomings that they have.
I think it is open source large language models. I think this year saw a lot of open sourcing and open access large language models released. OPD, Bloom, Galactica, UL2, and so on. So I think that was super exciting. We hadn't seen this rate of open access models released before this.
There have been a lot of really interesting developments in the area of building larger and larger models. Particularly ChatGPT coming out this year has really been inspirational for a lot of people in the field and people outside of the field who are also inspired by all of the advances that are happening.
Well, to me, the most exciting idea is the one that called from ChatGPT, because it's putting the text generation in the context of dialogue and taking into account the dialogue history.
The idea of using rationales to try to increase the performance of very many different natural language processing tasks is the thing that I'm most excited about now.
The second question was, what are you excited to see in 2023?
I think a lot of people are going to start working on reinforcement learning with human feedback, ranking, and trying to figure out how to align language models to what human beings want to see. So I guess it is the RLHF.
So I would love to see more work that is being done to address some of the problems that are being generated because of these systems themselves. So the more work, regarding ethics, biases that are embedded in these systems, how we deal with them, and that doesn't necessarily just mean the bias in the model, but also the biases of building such models that are, very expensive to build, which mean they're not accessible to a lot of people, and then they will come with a cost. Who can use them? What are they being used for? I'd love to see more work in the direction of, can we make them a bit smaller and more robust somehow, right?
I predict that we'll see more of the same, hopefully in more multilingual versions, so that hopefully there will be more large language models that are as good as ChatGPT or any of the other latest models, but instead of focusing on only English, hopefully they'll be multilingual like Bloom, and through that a lot more people can play with them, a lot more people can be reached by them, and we'll also hopefully see a lot more applications built on them that can help people write texts or code or revise texts, and through that also make the whole research more accessible again.
more focus on factuality in text generation, because there's a lot of hallucination, and we have very nice models, but if you cannot trust them, this really limits their usability.
I'm excited to see whether or not there are shortcuts or not in this use of rationale and more explicit reasoning to solve classification decisions.
And the final question I asked was, what's one idea that you think is underrated and the community should be putting more focus on and should be thinking about a little bit more?
Evaluation, and I think evaluation is a very hard problem, especially for large language models. How would you evaluate ChatGPT, and how do you know like it's actually doing what it was trained to do? And even though it apparently is really good, it is also like very convincing at misinformed things, and it can be a tool for spreading things that are just factually incorrect.
Yes, I think a very critical topic where NLP will not play a central role but will play an important role is the avoidance of language death. So we have 7,000 languages currently spoken on the planet Earth. They're dying at a very high rate, and within 10 to 20 years we'll lose thousands of languages, and perhaps in 50 to 60 years we'll be down to just 12, 14 languages if things continue as they go now. And so it's critical that NLP figure out what role it can play in avoiding language death.
I'd love to see a lot more work on bridging the symbolic space with the neural space, a kind of neurosymbolic and hybridization in general. And I say this because in the history of the field, I've been 25 years working in NLP, and I've seen this pattern before when people were doing a lot of symbolic NLP, and statistical NLP became, or statistical models in general became, more feasible because we actually have resources that can handle them, computers, memory, etc. So we saw kind of these improvements in one side of this equation, but then eventually people basically started coming back together and looked about hybridization between the statistical and the symbolic. And now we're going through that same time again. Some of the challenges that we work on in our lab, although we specifically work on Arabic, but a lot of what we can do and learn can actually be applied to other languages, is basically about providing ways to control the performance of these systems. For example, we know that, I'll just pick one case of, there's gender bias that exists in these models. In some cases, we think the gender bias is actually, it doesn't matter if it's in the model itself, as long as, in fact, in the system that uses such model, there is no information to control and direct toward the right gender preferences, for example. So bringing in the user, developing better HCI systems, etc., to make these powerful models that are so exciting actually useful to people without actually creating more problems for them. We believe one approach to this is to actually have some of this neurosymbolic approaches or hybrid approaches coming together.
Working on factuality, disinformation, propaganda, bias, fact-checking, and so what I think we should what should look at is putting the human in the loop and thinking of what fact-checkers actually need. And I have been working on this for a while, but I'd like to see this more mainstream. Number one, what is interesting to fact-check in the first place, kind of claim extraction. Number two, detecting whether it was previously fact-checked.
I think more focus on evaluation, resource creation, multilinguality. These are all topics that are growing in importance and obviously have always been important, but growing in awareness as well, growing in popularity to work on. We need, I think maybe that's another controversial or strong opinion of mine. I think where we're going as a field is more smaller data sets in our evaluation that have a very, very clear evaluation story, rather than one large data set with hundreds of thousands of examples that we can fine-tune on for 2 weeks and then get one model that has one task and only that one task. Because we now have these multitask models, and that is something I think where we're going as a field, is that we will build a lot more data sets with 500 examples, 1,000 examples, but that are really easy to evaluate instead of having unclear evaluation for large corpora.
I mostly spent the first day of MNLP at the GEM workshop. It's the workshop for generation, evaluation, and metrics. This was the schedule. There's a lot of content in here. Maybe a better way to introduce this is by speaking with one of the organizers. This is Sebastian Gierman.
A large motivation to start the GEM workshop, for example, was that we were coming together as a community, being fed up with how bad evaluations are. It's, I think, growing in awareness how bad they are, but we still see over and over again how people use bad data sets, bad metrics, and not necessarily to a fault of their own, but because that is the standard that is accepted in the community. And hopefully we can fix that by making people more aware of all of these shortcomings.
Another workshop I spent some time looking at is this massively multilingual NLU. A lot of interesting work on these models that are trained on many, many languages. Super interesting data set and challenge as well. But then for the second day, I spent most of the day in the Blackbox NLP workshop, which is one that I've been following for a few years. I think this is maybe the third or fourth time it's done. So there are links to all of these in the description, and I urge you to go to these. The Blackbox NLP specifically focuses on machine learning model interpretability and explainability. So how we explain models' predictions and how do we interpret sort of what goes on into them. There were 3 fascinating keynotes. I suggest you check out all of them. One of the keynotes is one of my highlights, honestly, of MNLP, is David Bau's talk here about Rome, about this method of interpreting neural networks in a way where we can edit information in their memory cells. The full video is here. You can go and check it out. I highly, highly recommend you check this. I'll give you a quick preview over the first part here. Talks about you know, some of the work they've been doing on GANs, on these models that generate images, you know, before Stable Diffusion, before DALL-E, before like diffusion models. A lot of the fascinating image generation was with GANs, and they were working on this method to explain, or let's say understand more of the neurons in these models. And they were focused a little bit on the lighting and like the lamps and how these, all of these are generated images. These are not actually pictures. But they were focused on, you know, trying to look for, you know, the neurons that focus on, let's say, the lighting of the lamps. And when it got to this section, this was breathtaking to me. I was literally, you know, I had tears in my eyes looking at this. So what is going on here is that, you know, they've identified neurons inside these GANs that if you've tweaked their activation value, that directly changes how much light the lamp has in the generated image. And you know, they can showcase this with these sliders that you can move, and if you decrease, you turn the lamp off, and if you increase it, you turn the lamp on. So this is the level of control that was able, that this interpretability technique was able to exert on this generation of images, of changing this one variable. And it's something that's absolutely phenomenal, and we don't yet have in a lot of the more advanced methods that we have now. So you would generate, you know, a Stable Diffusion image, but you want to tweak one thing, but then, you know, you tweak the prompt a little bit. You don't have that sort of control over it. So really excited to see a lot more work in explainability. But then, you know, this is not the most mind-blowing part of the talk yet. That comes later when they talk about GPT models and sort of editing the information inside of GPT models. I am fascinated about this topic. I worked in the past on this library for explaining models, so transformer models, and so seeing this was just like music to my ears. So again, I got a little too excited about this, but this is one of my highlights for my MNLP experience. And you know, the link is down below. You can watch this talk, and I highly recommend you do. I also have an interest in Arabic NLP, and so that workshop I stopped by as well and attended a few sessions there. Aside from the presentations and talking with people, there are a lot of posters, and posters are this way to showcase papers that people wrote. There are so many of them, and so many really good ones. I only got to catch a few of them and record even less. And so here's a couple of poster presentations that I found interesting. And the first one is about, really, this idea is one of my main focus areas, I think, for the conference. I was on the lookout for this idea, and I think will be one of the biggest ideas like we'll see in 2023, which is retrieval-augmented language models, which is having a large language model or a GPT-like model that is able to search or have the ability to access information stored in a database or in the web or somewhere else. This poster presentation talks about a method for retrieval-augmented language models.
I'd like to start with introducing what is knowledge-intensive NLP tasks. They are the tasks that require accessing external knowledge. So, for example, for open domain question answering, the user asks the system a question, a general open domain question, right? And so the system will have to go to access to find relevant documents from Wikipedia or from the web and to answer the question. So here, for example, if say a user asks like when did jazz originated, right? Like there's no context given, and the system will have to go find relevant documents about jazz. So a common approach to solve these sort of tasks are what we call retrieval-augmented methods. So they retrieve relevant documents from web or from Wikipedia, prepended it with the input. So it's usually a very long document and prepended with the question, and feed it forward to the transformer blocks. But that would be very slow and costly because the sequence is very long, right? Another approach is what we call a parametric method, essentially just having a larger model, like larger language models, and increasing the scale of models to memorize a lot more facts. But that's not going to work really well too, because parametric models doesn't seem to scale that well to learn a large amount of knowledge. So in order to incorporate these best of both worlds, and we propose a memory-augmented transformer model, which uses a key value memory to augment the knowledge capacity of these transformer models.
Another big and important idea is evaluation. This is a poster presentation about that.
So we introduced a centralized leaderboard for human evaluations. Thank you. So now we have many generation models, but our human evaluation methods are really diverse and not really centralized, standardized, but we propose a leaderboard that standardizes human evaluations for you. So model developers who develop generation models, they can just submit their outputs on the test data on our leaderboard, and then we take care of human evaluations. We use the same templates for different systems to make sure that our evaluations are consistent.
What is machine learning without the big data sets that we have? This is a presentation about the Bloom dataset.
This poster, it's about the Bloom library, which is new multimodal data sets across 300 plus languages. So the Bloom library is actually an online, it's a website and a software package. It's free and open source from SIL International, and it's meant to really promote the production of literature in local languages. So local language communities around the world use the Bloom library and the corresponding software to create books in their own languages. They also record these sometimes in audio in their language, and there's even sign language videos associated with a lot of these. So we saw the value in this, that there's, I think right now, around 12,000 something books on Bloom across 500 something languages. And we saw the value of this in the sense that we have text aligned with images, We also have audio aligned with those images and text, and so we saw this opportunity to create a number of data sets out of this. But the first ones that we're presenting here are for language modeling, image captioning, speech recognition, and visual storytelling. And yeah, we hope that this kind of promotes more linguistic diversity in the study of these different NLP tasks. And check us out, the Bloom Library data sets are on Hugging Face. If you search for SIL-AI on Hugging Face, you can find them there, along with some of the baseline models and other things. And yeah, I would like to acknowledge also contributions from Masakane, who helped us with this project, and also Anna at the Technical University Darmstadt, and Colin over here at the University of Dayton.
The final one was this very interesting method of playlist captioning, music playlist captioning. So how you can assign a name to a playlist given the songs themselves. So this can be multimodal, where the model can actually either see the names of the songs, but also I think the audio of the songs.
So this poster is about playlist captioning, which is the task of given a sequence of songs, generating a caption. And here's an example, like caption can be French pop, so all the hits from the 2020s French pop scene. And you see that the caption should be relevant to the playlist content. Yeah, this task is very challenging because it's, it's music to text translation, and it's also very sparse because the datasets are very small usually.
So the dataset is the playlist. Is it the lyrics of the songs, or is it the actual sort of music, or the names of the titles? What is the...
So we start just from the name of the songs and the artist names.
Okay.
But from there we retrieve the audio, so the actual signal, and the tags of the songs, which are crowdsourced. So there are data set online of tags of songs, and as well as this artist distribution vector, which is very much handcrafted. So yeah, we propose this model, which is multimodal because it does music to text, and it's also data efficient because it works with small data.
There are links for all of these papers and workshops. So if you want to learn more, you can click through to them. And with that, this has been just a quick look at my MNLP journey or experience this year. I hope you find it useful. If you like this, you're welcome to subscribe, and let me know in the comments or in Twitter if you have any thoughts how I can make these better. Thank you for watching, and see you in the next one.